evening, my YouTube viewers. In this particular video, we're going to be talking about experimental Latin square design. And this is part of an experimental design and statistics. And so there's 6 things that you have to do in order to do experimental design. And that is 1, define the research objective. 2, define the research methodology. 3, conduct a literature review. 4, develop research design. 5, collect and analyze data. And 6, present empirical findings. So what I've done is I've got some data here to talk about fertilizers. And so we're going to do a Latin square, experimental Latin square design. So you've got rows. So you've got a row 1, 2, and 3. That is part of row 2 to 10. And then you have columns 1, 2, 3, 1, 2, 3, 1, 2, 3. And then you have treatment yield 1, 2, 3, 2, 3, 1, 3, 1, 2. And then you have the data that we plugged in for the row, column, and treatment yield being 5.2, 4.9, 5.1, 5, 4.8, 5.3, 5.1, 5.4, and 5.7. So, and now what we do is we do put it in a square. So you've got row 1, row 2, and row 3, and then you have column 1, column 2, and column 3. So you break it down, and row 1, column 1 is 5.2. Row 2, column 1 is 5. Row 3, column 1 is 5.1. And then you've got row 1, column 2 is 4.9. Row 2, column 2 is 4.8. And row 3, column 2 is 5.4. And row 1, column 3 is 5.1. Row 2, column 3 is 5.3. And row 3, column 3 is 5.7. So we've got our Latin square design here. And so what we're going to do is we're going to carry out an ANOVA, which is a 2-factor without replication. So you come over to the data ribbon, and then you go to data analysis, which is what we're doing. And so ANOVA, 2-factor without replication, and you click OK. And so your input range is going to be, G2 to I4. And then, or if you wanted to say, it could be G1 to I4, and then you'd have labels. You click over here, G1, I4. You click over here for labels, and then you click output range, and then for the output range, you would say F7. But I'm not going to click that, and the reason why I'm not going to click that is because I've already done it. So we've got a 2-factor ANOVA without replication. So an ANOVA, that's analysis of variance, and you do an ANOVA when you have 3 or more samples of data. And in this instance, we've got 3 samples of data. So you've got your summary, your count, your sum, your average, and your variance. But what I might do is new data analysis, 2 factors without replication. Okay. And what I might do is I might say F1 to I4. And then I might say a new worksheet, set it up for a new worksheet. And then I'm going to click OK for a new worksheet. And I'll move that over here. So we've got our two-factor without replication, and that looks better to me. That looks a lot better than what we previously had. So I'm going to come over here, and I'm going to clear contents. I'm going to clear contents. I'm going to format cells. Okay, so we've done all that. So now we've got over here, so we're going to have F7, I think. So we're going to come over here and we're going to go over here to sheet 1. So basically what we've done is we're going to delete sheet 1. So here we go. So that I just felt that looked a little bit better. So we have summary, row 1, row 2, row 3 is a count of 3, and column 1, column 2, column 3 is a count of 3 as well. And then we've got a sums and average and variance for row 1 and column 1. And then we have the ANOVA, which is the analysis of variance. So you've got your source of variance, so you've got your sum of squares for rows and columns, and a total of points and error, and a total of 0.6. And you've got your degree of freedom being 2 for rows, 2 for columns, 4 error, so a total of 8. You've got your MS, you've got your F statistic, which is 2.96 for rows and 2.22 for columns. You've got your p-value, which is 0.16 for rows and 0.22 for columns. And then you've got your F critical being 6.94 for rows and 6.94 for columns. So basically, we have a p-value for rows and a p-value for columns. And both of those p-values are above 0.05. So that means that the null hypothesis would be accepted for rows and columns. So for rows and columns, you would get the null hypothesis. You would fail to reject the null hypothesis. But I'm not going to do that because we don't have a total p-value. We just have a p-value for rows and then a p-value for columns. And then we get the fertilizer field for rows 1 to 3 and then columns 1 to 3. And according to the analysis of variance, The p-value for rows is above 0.05, and the p-value for columns is above 0.05. So that means you have to accept the null hypothesis, meaning there's no significant difference between the samples in the rows and the columns. So that's it for our analysis of variance in the fertilizer yield experimental Lattice square design, and the next video is going to be on the experimental plot design and split plot design. So I hope that you decide to watch it.